Okay, here we are with the data that we're going to use to examine this thing called regression. Now, if we were to take the data, now what this is recruitment data, and it looks at several recruiters across the country, the number of students they recruit per month, the number of emails they make per day on average, the number of calls they make per day on average, the recruitment bonus they get, if any, for every student that they recruit, their age, and their years of higher education. And this is the kind of data that you will normally get, and you're supposed to find relationships if they exist. And one of the ways that you can do that is using regression. Now, the simplest form of regression, a linear regression, is when we take one output and one input and try to see if there's a relationship between the two. Now, one of the things that I'm assuming that there's going to be a relationship between is recruitment bonus and recruits per month. I figure the more motivated people are, the more they're going to try to recruit. So to do that, to take a look at this, we would, well, first, let's take a look at something else. If we were to highlight this data, okay, and create a chart of it, we can see that the data in the chart tends to go up in a line. That the higher the bonus, the more recruits per month in general. Now, it's kind of wide, but we can see that there's definitely a relationship here in this data. And what we're trying to do is to figure out what is the equation that gives us an idea of what these values are going to be. And to do that, we do regression. So let's take a look at that. So let's cut this out. And we want to go to data, data analysis. If you don't have data analysis there, I have Excel 2010. You're going to go to File, Options, Add-ins. At the bottom of Add-ins, it says Manage Excel Add-ins. You're going to hit Go, and you're going to check the Analysis Tool Pack and the Solver Add-in if you haven't checked them already. All right, so we want to go to Data, Data Analysis, scroll down the list, you get to Regression, and click OK. Now, your Y range is your dependent variable. That is the thing you don't know yet. And so what we're trying to figure out is how to make people better recruiters. We don't know how much they're going to recruit per month, so that's our Y. Our X is the recruitment bonus because we know how much we're going to pay them as a bonus. That's our choice. Hello, Hoyan. All right. Yeah, 2:30 is fine. Yeah, macaroni grill. All right. So with these two settings set, the one thing that I have to make sure that you do is to click on labels. Because I included the titles at the top of the columns, I have to click labels to let it know that the labels will be there. If I don't click it, it'll give me an error. Input range contains non-numeric data because it thinks that there's words in the data that we're asking it to regress. So we make sure labels is clicked and click OK. Now we have our regression data, and it's a lot of information. And let's take a look at the key pieces that we need to know. The first thing that we're going to look at is the R squared. The R squared represents the percentage of the variation in the data that's accounted for by the equation that will come out of this regression. So what we're saying here is this regression represents 73% of the variation in the data, which is pretty good. I like to make sure that my R squareds are 70 or better, if at all possible. Some people pick a lower line of 50 for statistical purposes. That makes sense. For health purposes or safety purposes, that makes sense. But when it comes to making business decisions, I like my R squared to be higher. The next thing that we're going to look at is the F statistic, or really the significance F. What this number represents is the percentage chance that these regression results happened by luck. that it was just luck that we ended up with this, and this isn't really the proper results for this situation. Now, in general, as your observations go up, your significance F is going to go down. And so on this particular set of data with 500 observations, we can see that our significance F is 2.66 times 10 to the negative 146. When you see this with the E and the negative 146, that's what that means. That's scientific notation. If you're not familiar with that, you're going to want to Google it and look it up. But 2.66 times 10 to the negative 146 is less than 1 in a million. It's a very, very low number. So we can feel really good about the fact that there's almost no chance that this happened by luck. The next thing that we're going to look at is the p-value. Now, what the p-value represents is where the significance F talked about the regression as a whole. The p-value represents the percentage chance that this one factor has nothing to do with the regression. So what is the possibility that the intercept is not a part of the equation, or that the recruitment bonus is not a part of the equation? I like my p-values to be less than 0.05. Some people draw the line at 0.50, again, for statistical purposes. In a business context, if at all possible, I want to be more certain, so I like them to be less than 5%. When we take a look at this, we can see that the intercept p-value is 9.57 times 10 to the negative 70, and the p-value for the recruitment bonus is 2.66 times 10 to the negative 146. Both of those are awesome p-values. So clearly, there's almost no chance that either the intercept nor the recruitment bonus are part of the equation. So given those values, we can go ahead and create our equation. Now, you're probably familiar with the point-slope formula, which generally has the format y equals mx plus b. What we have here is something similar to that, but instead what we're looking at is recruits equals m bonus plus b. So it's basically the same equation. Y equals mx plus b, with where y is what you're trying to get and mx is what you already know. Recruits equals m bonus plus b, where recruits are what we're trying to figure out and bonus is what we're putting in because we're deciding what the bonus will be. All we need to figure out is what the m and the b are, and that's where these two coefficients come in. Now, these coefficients here are Excel's best guess at what the m should be and what the b should be. But if we look over here, what we have is the 95% interval. And what that's telling us is that Excel is 95% sure that m is in between 0.00388 and 0.00431, and that b is between 1.972 and 2.383. Now, when it comes to finance and accounting, for that matter, there's this concept called conservatism, where you try to use the most conservative numbers possible. You try to use the highest cost, and you try to use the lowest revenue, so that when you come up with an answer that says something's going to be profitable, you can be certain about it. You don't want to use pie-in-the-sky numbers, because if you're even a little bit wrong, then everything goes to heck. So instead of using these coefficients, the best way to do it would be to use these lower 95% coefficients. So since we're 95% certain that the m is in between this and this, and the b is in between this and this, if we use these lower bound numbers, then we can be 97.5% sure, we can be really, really certain that the equation is at least this or better. Okay? And if we're doing that, then we're putting ourselves in a situation where even if we don't have the exact right value, it is something different. Odds are any error that we make is going to be better than where we are now. So what the equation would look like would be recruits equals 0.003883203 times bonus plus 1.972768421, and I am 97.5% certain that it's at least this or better. Now, for a lot of people, that makes it a bit nebulous. So, for the purposes of simplicity, what they just use is the coefficient values here, and they just want to make sure that the signs stay the same where they are on the averages for coefficients as they do within the range. Because if there's part of the range where the sign changes, then that means that within our area of certainty, sometimes the effect that a particular factor is opposite than it is normally. And that is the situation that we want to avoid. But the long and short of it is that some people prefer to use the coefficients. And in that case, the equation would be recruits equals 0.004 times bonus plus 2.1782. So this is a very good estimate of what the equation would be. This would be the most conservative estimate of what the equation would be with the level of certainty. For my bachelor students, I generally ask them to use this equation because it's simpler to remember. Just take the coefficients, plug them into the equation, and keep it moving. Also, for my bachelor students, I'm only asking them to look at the r-squared and the p-values. For my master students, I'm going to want you to take a look at the significance f, and I'm going to want you to look at the upper or lower bounds of your confidence intervals, so that you have an understanding of exactly what it is that you're suggesting.